Hello everyone, I'm Xiao Gang. Okay, in these lessons, we'll be writing the damage numbers. Damage numbers are simple, but they are also a very important task because they affect the game's feedback field. So we are referencing Laura for this. In this fed, we have prepared a few folders, but we haven't written anything yet. We'll start writing now, and we'll define a component and attach it to our control. Then, once damage is dealt on our client, we will get the current person dealing the damage, whether they are player. If it is the player, we will just generate the damage number on their client. It's quite simple. There are many ways to handle damage numbers. We take a relatively simple approach. We generate an actor in our scene, and this actor has this UMG attached, and then it's done. Then we play a rise and fall animation on the UMG. Okay, so here we will first write the files we need one by one for everyone. First, we define a G class. This G class is specifically used by us to handle this rise and fall number because other modules, no other class cares about this. Doesn't care about how this is implemented internally. They only need to know I just need to attach any subclass of this component. Then it can implement, calling the corresponding interface, and this functionality can be achieved. So this way of writing is implemented through UMG, so we give it a suffix later. Obviously, this class is its subclass, right? Okay, we simply change the name here. As for the actor here, it is the object we want to generate in the scene. So first of all, what do we write? Let me think. This is still a bit tricky to handle. So let's define this command first. Write this command first. As for this command, we are program advanced, right? Then, this command, it is an inherited value. Actor command will do, because it's a bit different. It only does one function. We won't let it. Because it is mounted on the controller, it might be different from the logic of being mounted on the character. So we should not let it inherit in a mixed way. Because they're owner, or called outer. Note owner and outer. These two concepts are actually not quite the same. Not quite the same. It is where we attach. This component, it is a controller. The logic is not quite the same. Then we definitely need some tags. Okay. Then we definitely also need a reflection file. Let's forward declare it. Then when we do it, let's define something like this. That is, we define every time we call listener, what parameters we need to pass. Then these parameters definitely have many redundant settings. I brought them over here for comparison. Let me explain to everyone. This is for generating a damage number. We need to write parameters. First, you must be clear about where this position is generated. Right, then that is, it definitely has tags for both sides. For example, this tag has ice, and its tag has fire. Then you might trigger an ice and fire special effect. Such that is fire with a hint of blue, but we are not doing that design now, so it won't be used. So this is a potential design, and this is about how large the number should be displayed and whether this is a critical hit. If it is a critical hit, then it might be enlarged and bolstered. And if it is bold, then you should actually move this tag up here for the critical hit. It can be merged, that's fine. Then this is its constructor. In our writing style, this falls in little 0. It actually overloads this enumeration structure. Regarding the constructor of this struct, let it be equivalent to giving it a world origin position. And this one, we wrote ourselves. We won't make it too complicated. We'll just use red to represent damage, green to represent health regeneration, blue to represent mana regeneration. Then later we'll explain to you about mana or other similar consumable resources. Okay, alright. After doing this, now let's go write our component. So first of all, this component, it must be an abstract component, right? Because it only has interfaces, right? Okay, then it must have a constructor, and for this interface, actually, this is all that's needed. So we just need to pass such a request. Then we paste it here. Okay, we just need to call its parent class in the constructor. Let's check the include relationships. Remove it. Okay, now we need to make sure they compile successfully. It should be passable. Then next we are going to play with the implementation of this composition. That is to perform corresponding functions based on our parameters. But before we do that, we might need to first prepare the various subclasses. Let's first go to the UI side. It should have, we find our UI, there is a damage here. There are 2 folders here, right, so it's these 2 folders. As for these 2 files, we give them a UI. This is one of our UMG. Okay, let's change this name. Let's write this UI first. Because this thing is all put together, I have to start writing from the smaller components. This UI is relatively simple. First, it's still the same. We include this minimal dependency, then the header file and the reflection file. And actually, it only needs 1 text box. Yes, and for this text box, we provide 2 parameters. We can directly modify its color from the C++ level, as well as the number it displays. Then let's just write it. It's too simple. This UI is really all very simple. Then, in this function, we directly get our text box, and then just set txt for the color. What we pass here is the flannel color thing. Just pass it a color directly. And note that our constructor is a bit special. The constructor is written like this. We call what we wrote in the parent class display animation. So when we are in blueprint, we need to key this fade animation. In our blueprint, we need to bind this text box and then bind on animation. And this is our UMG part. Of course, it should compile successfully now. Then on this UMG, we need to attach an actor. So now we need to make this actor. Is it the damage actor? This is the actor that displays the damage value pop-up. There's an error here, right? Let's check what the cause of this error is. It says here, we often encounter this kind of error. It says here that the reflection file cannot be found. Let's check it. Should take a look. Why can't this reflection file be found? If it can't be found here, maybe take a look. Here. Wow, this is a bit strange. Oh, mate. Not exactly the first time, but it's been a long time since I encountered this kind of error. I can't figure out what's wrong with it for the moment. A bit strange. Then let's just delete them all. This doesn't matter. I know where the error is because our CPP and H files are coordinated. Interesting. This error, interesting. I mean, I didn't see the method. This is also very normal because sometimes when you're writing, you know how to write it, but instinct might cause you to write it wrong. At that point, the compilation can still pass. Actually, when you write code, it's often best to take a single feature and break it down into several steps. First, set up the framework, then compile it to make sure it passes, and then gradually fill in the functionality. If you try to write everything all at once, it's very unfriendly for beginners because you can easily lose track of where the error is. When checking at the end, it might have been written incorrectly from the start. That's entirely possible. After preparing this UMG, go to this pop-up actor location. It should be here. This actor is also relatively simple, but the writing style might be a bit special because we are using this hybrid writing style. First of all, it's still the same. We include this header file. This actor, we should have written it like this often. In the first 20 chapters. Here, we include the reflection file. Then here we include the component we want to use, the widget component. This component is specifically used to do this in the actor. Attach the actor to bind this UMG. But note that it is a component. It is not a UMG. It is a component. It actually inherits from mesh component. And this mesh component actually inherits from primitive component. And primitive component inherits from scene component. So you need to clearly understand this inheritance relationship. Then for this part, first of all, we still calculate this actor. And note that the semicolon here cannot be omitted. Okay, so after we write it, 能找得起第一次就睇能 there must be a root component here, and then we have our widget here, right? And here we need to expose the relevant methods, because directly calling this UMG is very troublesome. Since it is attached within a 3D entity, you must go through the actor to find this UMG. Okay, so now we start writing our constructor, creating it directly like this. Should be fine. It should be able to contain the same key. Then let's create these two methods. Okay, so in the constructor, how should we write it? Because in the constructor, first of all, we create a default new canvas panel as our root node. Then we take our root canvas and assign it. Note that we include this. We need to use this key. They are respectively the widget switcher component and the damage, a UMG we just wrote. Okay, then we definitely don't need this stick. We'll just force it off. Then now we go create our widget component. Note, it's the widget component, not widget, not UMG. Okay, then here we attach it to our root node, to the root node. And at the same time, we force all these collisions off. We don't need collisions. Then we initialize our lifespan to 4 seconds. Okay. Then, regarding changing the color and numbers here, we need to determine our current DamageNumber widget. Actually, it's better to write this as a component. Let's give it a component name. Because many junior developers actually get confused about when it's a widget and when it's a widget component, because they are two completely different things. When this component exists, then we get its user widget, and this will return a UMG. Then take this user widget and forcefully cast it to the UMG we wrote. Then we go to call the method inside it. Then it should work like this. Then similarly, the update below is the same. That is, through this component, get the UMG instance that this component points to. Then call the method inside it. Then we have basically finished writing this thing. Okay, now let's compile it. There is an error, right? The reason for the error is that we didn't change it here, because we added the word combo to it. Let's compile it again now. Okay, compilation successful. Now that we have this act, then we need to spawn it. Now we come to our feedback here. Take a look at this feedback. Where did we put it? It should be here. No, it is in this UMG. First of all, we still have this include program once, just like the header file. Header files all need to include this to make it compile only once. And then here should this tag be included? Then the control combo should be included. Then go ahead and take this. Actually, we don't need to. This control combine is not used, probably, but let's leave it here. It's fine. Then we take this, the actor we want to generate, give it a forward declaration. Then here we take our the blueprint we want to make. We'll get it done, and then we give it a public. Okay, with it, we write the constructor. Then the interface we want to implement, also write it. And finally, we need to specify one thing. That is which extra class we are actually using. This can facilitate configuration, because we may have multiple extra classes. So there is a deepstrap class. Here we create their respective implementation. When we come here, include the header file. Mainly include the header file of the object we want to generate. Okay, then when we receive this pop-up, we can compile it now, no problem. When we receive this pop-up request, we must check that this component, we see an error. It should be because we didn't write a semicolon here. Okay. We must check that our player control must exist, because if you are not on the player control, then it proves that this logic is problematic, because this component will only be used on the player control. So we don't need to worry about then here, in this place, it also gives a series of this code. We can paste it and tell you what it means, but we shouldn't use it this way, because that would be a bit troublesome, and it's not very accurate. The meaning of this section is actually to get this. That is first give the transform of this camera. Then we want to know where to generate it. This generated position. We set it by default to the position we pass in the request. This part is to check. If we can get this camera management class, we go to the camera to get some camera view positions or rotation, etc. And then we do some offset to it. 计博博至完万体至奥. And then actually we don't need to worry about it. Then here we directly get the world. And in get world we generate our object. After generating it from this request, we can directly paste this number in. Okay, so this code can be completely ignored. This code doesn't have much meaning. It's just that when you want to optimize the effect, you can take a look. Because it's code from Lyra, this code is meaningless. Removing it won't have any impact. Okay, let's compile it now. Okay, so we have actually defined everything. Next, we need to go to our player controller to instantiate it. And you might think, why do you need to write 1, 2, 3, 4, 5, 6, 7 for such a simple function? So many classes and so many lines of code. As for this thing, let me explain it to you. It's just that it's a kind of trade-off in development and design, a way of thinking, because after you split it like this, it might be that this player control is not maintained by you. That is, you might only maintain this damage component, right? So that's what it means. Here, we'll just let it use this component. Okay, alright. Now that we have such a component, we need to prepare. We also need to prepare such a method. To make it convenient for it to retrieve it, of course we can write it as force inline. Here we get the parent class component. It doesn't really matter. Let's also add a forward declaration for it. We should add the forward declaration here. It seems we didn't write it before. I think it won't affect anything. Okay, let's create the implementation for this. As for the implementation of this, it actually just directly returns this component, and mainly in the constructor, we need to instantiate this component. This is the damage pop-up number component. As for this component, we do not allow network synchronization. Even on the client side, we don't even need to create this component because on the server side, there is no need to create this component at all to save memory. Right. Okay, but we didn't write that here. We'll just let it be created anyway. Okay, so then on our end, at the Z++ level, actually just take our damage pop-up logic and get it done. But we also need at our blueprint level to configure and specify the specific resources. Then at the blueprint level, add our business logic. Only then can we complete the display of damage numbers. Okay, that's all for this lesson.